Now let us consider a parallel combination of resistors AB and CD with resistances R1 and R2 connected as shown to a battery of potential difference V. The equivalent resistance Req of this parallel combination is obtained as follows. The charge that flows from the source, that is the battery, splits and flows out partly through R1 and partly through R2. I is the rate of flow of charge from the source, that is the battery. I1 is the current through resistor R1 and I2 is the current through resistor R2. We can now write I is equal to I1 plus I2. Let this be equation 7. Applying Ohm's law across R1 and R2 individually, we can write V is equal to I1 into R1 and I1 is equal to V by R1. Let this be equation 8. Voltage V applied across the two resistors is the same as they are connected parallel to the same battery. Therefore, we can write V is equal to I2 R2 and I2 is equal to V by R2. Let this be equation 9. Substituting equations 8 and 9 in equation 7, we get I is equal to V by R1 plus V by R2 and I is equal to V into 1 by R1 plus 1 by R2. Let this be equation 10. Equation 10 can be rewritten in the form I is equal to V into 1 by Req. Let this be equation 11. Req is the equivalent resistance of the parallel combination of resistors. From equations 10 and 11, we can write 1 by Req is equal to 1 by R1 plus 1 by R2. Let this be equation 12. Using equation 12, we can calculate the equivalent resistance Req of the parallel combination of two resistors. Similarly, when there are n resistors connected in the parallel combination, we can write 1 by Req is equal to 1 by R1 plus 1 by R2 plus and so on up to 1 by Rn. Now let us consider a situation where some resistors are connected in series and some resistors are connected in parallel. The equivalent resistance of such a series and parallel combination is obtained as follows. In the circuit, 3 resistors of resistances R1, R2 and R3 respectively are connected in a mixed combination. R2 and R3 are in parallel combination. Their equivalent resistance R23EQ is calculated using equation 12. 1 by R23EQ is equal to 1 by R2 plus 1 by R3. Now, R1 and R23EQ form a series combination. Their equivalent resistance R123EQ is calculated using equation 6. R123EQ is equal to R23EQ plus R1. We can calculate the equivalent resistance of any combination of resistors using the basic equations 6 and 12.